In this video, we're going to be doing a brief introduction to interval notation. So let's start with a little definition just so we can kind of get rolling. So first of all, interval notation is a special type of notation used for writing inequalities. It's really a way to kind of shorthand when we're talking about particular intervals. So if I'm talking about, for example, let's say I had x is less than 2, we would use interval notation to kind of shorthand this. Or even if I'm talking about a compound inequality like this, interval notation is very much a shorter way to write these things and still mean the same thing. So the two big symbols that you need to know for interval notation are the brackets, and you need to know parentheses. So brackets are used when a number is part of the solution. And by solution, we could also call this the range. If we're talking about a particular range of numbers, we're talking about a solution, we're talking about a domain or range. So it could be part of that group of numbers. So if it's included as part of that group, we use a bracket. We use parentheses when the number is not part of the solution or the range of values. So if it's not included, so for example, this 2 would not be included in this set, we would use a parenthesis. And in this -3, it is included because we have this equal to, so that means we would use the bracket. So a kind of short way to think about it is that when we see a less than or equal to or a greater than or equal to, we're going to use a bracket. And similarly, if we have a less than and a greater than, we're going to use a parenthesis. So these are very much the replacement for those two symbols. So instead of using a less than or equal to, greater than or equal to, we use a bracket, and same thing for less than or greater than, we use a parenthesis. So let's take a look at what this would be. So here I've got two compound inequalities, and I have 4 is less than or equal to x is less than 10. So I want to start just by doing a very rough sketch of what this looks like. And if you remember on a number line, when we would do a rough sketch, we would look at the numbers between 4 and 10. And if you remember the idea of open and closed dots from graphing in Algebra 1, in this particular one, there would be a closed dot as 4, because I could put 4 in this inequality and it's a true statement. It's greater than or equal to 4. So that's okay. And then at 10, we would put an open circle because we do not have an equal to. And then we would connect those dots like so. So this is what that compound inequality would look like. We're saying x is between 4 and 10, and we're including 4. So to say this in interval notation, what we would start with is we would start with a bracket, because 4 is part of the solution. So we would say bracket 4, comma, and then afterwards we would put 10 with the parentheses because 10 is not included. So if you look at this interval notation, this kind of makes some sense because we see here, okay, the bracket tells me this is part of the solution, the parenthesis tells me this is not, and I can see that 4 is the start, and I can see that 10 is the end. So that's all this is saying. So just by writing these symbols, I can tell that my interval starts from 4, includes 4, ends at 10, but does not include 10. Let's take a look at another one. So for this one, let's do another rough sketch. So here I've got -3, and we'll go to 0. So if I look at -3, thinking back to graphing, this would be an open circle at -3. And then at 0, we would have another open circle because it's not equal to. So we're looking for all the numbers between -3 and 0. So let's write this in interval notation. So for interval notation, we would start with the parenthesis because -3 is an open circle. It is not included, so there's no equal to. -3, comma. We start at -3 and we go to 0 with another parenthesis. And we see my start, we see my end, and we know that neither of them are included because there are no brackets. Let's take a look going the other direction. So here I've got some intervals and I want to write them as inequalities. So I'm going to start with a sketch to kind of help me visualize what's happening. So according to this, I'm starting at 3. Remember, we think about our start, we think about our end. So we're going to start at 3 and end at 5. And then these brackets tell me that 3 is included, meaning I would put a closed dot at 3, and I would put a closed dot at 5 because that's also a bracket. So I'm looking at all the numbers between 3 and 5, including 3 and 5. So if I'm looking for the compound inequality here, I know x is going to be in the middle. So first of all, I know that x is bigger than 3, and it's equal to because of that closed dot, because I'm including 3 in this interval. And then 5, well, x is smaller than 5, but we're including it. So this compound inequality would be 3 is less than or equal to x less than or equal to 5. So that describes this interval. Try again. So here I've got 2 and 20. So 2, and then I'm going to 20. And let's see. So this tells me, the parenthesis tells me it's an open circle and an open circle. So I have two open circles here because they're both parentheses and they are connected. So I'm looking at the numbers between 2 and 20. So my interval here, if I'm looking at, or sorry, the inequality I'm trying to write is going to be x in the middle, compound, and x is bigger than 2. So I see x is bigger than 2, but at the same time, x is smaller than 20. So I'm showing all the numbers between 2 and 20 are part of my solution. Now these are not equal to because they are open circles. If they were closed circles, we would put equal. So here's what I want you to do. There are two more examples at the bottom. I want you to write these intervals as inequalities. So start with the one on the left, pause the video, try it out, and then I will explain in just a minute. Okay, so for this one, I'm going to do my rough graph. So I have a closed circle at 4, I have an open circle at 15, and I am connecting. So this tells me x is going to be greater than or equal to, it's going to be bigger than 4, but at the same time, it's smaller than 15. So I'm looking at x is between 4 and 15, and the 4 is included. And that's it. Okay, pause the video, try the next one. So same idea. I'm going to have a closed circle at 1 because of this bracket. I'm going to have an open circle at -5, then I connect them. So I'm looking at all the numbers between -5 and 1. So this would be x is greater than -5, but at the same time, it's less than or equal to 1. And it's equal to because of that bracket. Try these ones now. So we're going to go backwards again. So here I've got an inequality, and I want to write it as an interval, so using interval notation. So I'm going to start by doing a little number line here. So for this one, I'm looking at x is less than 3. So let's change colors. So I have 3, 4, 2. So notice that this is not a compound inequality. This is just a simple inequality, nothing too crazy. So if I'm graphing this, I'm going to have an open circle here at 3 because we can't say 3 is less than 3. That's just weird. And then I'm going to have an arrow pointing to the left because I'm illustrating that all of my numbers below 3 are solutions to this inequality. So for this one, having a start, quote unquote, let's do like that. So our start here is what? Where are we starting? Way over here on the left. Well, this is where we get to use the lovely infinity, because this keeps going to the left forever and ever and ever. That arrow tells me it goes forever to the left. So what this means is that my start here, quote unquote, is negative infinity. Now notice when you're dealing with negative infinity, you must put a parentheses. We never, ever, ever put a bracket negative infinity because we can never reach infinity. That's not how this works. We can never get there. So we put a parenthesis, negative infinity. I'm gonna know, where does this end? Well, this ends at 3. Okay, so the end is 3 with the parenthesis. So I'm starting way over here at negative infinity and I'm ending at 3. Let's try another one. So let's do a little diagram. So I've got x is greater than or equal to 9. So I've got 9. 10, let's do 8. So if I am writing this inequality or drawing it, I'm going to start with a closed dot at 9, and x is bigger than 9, so that means my arrow is going to the right. So I draw my arrow that way. So the start for this one on the left, my start here is 9. So we put a closed bracket with 9, because that's where I'm starting. And then my end, quote unquote, we never actually reach the end because I'm keep going right and right and right and right. So what's over here is I keep going right forever. Well, that's infinity. So my interval is 9 with a bracket to infinity with a parenthesis. Again, we never put a parenthesis around infinity because we're never going to get there. That's not how that works. Okay, let's try these two. So here I've got an interval, and I want to write these as an inequality. So let's see, I'll draw a little picture here. So I've got 3 to infinity. So I've got 3, 4, 2. So if I'm starting here at 3, I'm going to put a closed circle. So that shows me I include 3 in my interval. And then going to infinity. Now infinity is way over here to the right. So that means my arrow is going to go this direction. So if I'm writing this as an inequality, I'm looking at all the numbers bigger than 3. So x is greater than or equal to 3. Let's try this one. So again, I've got an infinity. So I'm starting, I've got negative 8, negative 7, negative 6. So at negative 7, I'm going to have an open circle because I see that parenthesis. And this says go to negative infinity, which is way over here to the left. So I'm going all the way to here to the left. So this tells me my interval represents all the numbers smaller than negative 7. So this would be x is less than negative 7, showing all the numbers smaller than negative 7. Now with intervals, there's another topic we like to talk about, and that's something called the union of a set and the intersection of a set. The union of two sets consists of all values in either of the sets. So union is when we take two groups and we put it all together. It's like we live in a union where we have all of our states. We combine to make one country. So that is a union. So if I'm looking at these two sets, I'm looking at A union B. Well, let's look at what numbers I have. Let's see, I've got 1, I've got negative 4, I've got 3, I've got 9. So all the elements of A and all the elements of B. Well, I've also got 8 and a 2, 8, 2, and I don't need to write the negative 4 and the 9 twice because I'm writing the union. So all the things put together. Now, the flip side of this would be something called the intersection. The intersection is what things these sets have in common. So if I have A intersection B, I'm looking for what they have in common. So in this particular case, I see they both have a 9, and I see they both have a 4. So my intersection here would be negative 4, 9. Now, the only other thing you need to know about sets, there's something called the empty set. So if these elements weren't here, let's say just like this, then the intersection would be the empty set. If we did not have anything in common, they would be the empty set, and we can't do anything with that. So the reason we're talking about this is because with inequalities in intervals, sometimes we can't put things together. So let me give you an example. So here I've got 5 is less than or equal to x, or x is less than negative 3. So let me draw a diagram. So for the first one, we've got negative 3 over here. Let's put 0 in there, and we got 5. All right, so for the first one, we have x is greater than or equal to 5. So let's draw that. So we have a closed circle on 5, and I'm looking at all the numbers bigger. And conversely, we have this one. We have x is less than negative 3. So we put the open circle at negative 3, and we're showing all the numbers smaller. So it looks like this. Now, both of these are part of a solution. So this is a solution, this is a solution. So what we're going to do is we're going to write two intervals and write the union of them. It's this interval plus this interval gives you our solution. So this one on the left over here is going to be negative infinity to negative 3, parentheses, because I'm going all the way to the left here, up to negative 3, union, bracket 5 to infinity. So we're saying that my solution are both sets, negative infinity to negative 3 and 5 to infinity. Let's do the same thing over here. So let's see, I need 6, 7, 8, 9. So for the first one, we've got x is smaller than 6. So it'll be x is smaller than 6, looks like this. And for the other one, we have x is bigger than 9. X is bigger than 9. Now these two don't intersect. So when we're saying our solution here, we're going to use the unions. We're going to say this one as an interval, union with this one as the interval. So the one on the left is going to be negative infinity to 6, because I'm going all the way out here to the left up until 6. Let's make it look like more of 6. Union 9 to infinity. So I'm saying both of those intervals are part of my solution. So the last thing we're going to do is we're going to find the union and the intersection for these two sets, for these two intervals. So I think the easiest way to do this is with the diagram. So I'm going to draw a quick diagram. So for the first one here, we've got the interval 1 to 5. So 1 will go to 5. And the other one is going to be 3 to 10. Now notice my dots here. Both of these are open because they're parentheses. The 3 is open because it's a parenthesis, but the 10 is closed. So if I'm looking at the union of these two things, well, if I take all of these elements and put them together, I can actually write this as one interval. Because you see I have all this overlap in the middle. So my union here, when I'm putting these together, is actually 1 to 10 with a bracket on 10. Because I'm showing all of these elements from 1 to 10 are a part of this union. Now let's do the same thing with the intersection. So with the intersection, we're looking for what elements do they have in common. So let's start with the red one. So we're going from 0 to 3. So let's just go like this, 3. And for the green one, we're going from 2 to 6, like so. So for the intersection, I'm looking for what parts or what numbers do these two things have in common. So if I'm going to use this diagram, I'm just going to draw a little section here. This little section is where they overlap. We're looking for what numbers are in both sets. So I can see that it starts at 2. Now for this one, is there a parenthesis or a bracket? There's a parenthesis at 2 because 2 is only in this set. See on this line, 2 is in the set. Here it's an open circle, so it's not in the green one. And it's going to end at 3. But again, is it going to be a bracket or a parenthesis? Well, it's going to be a parenthesis because it is only in the green set, not the red one. So my intersection here are just the numbers between 2 and 3, not including 2 and 3. So that concludes our tutorial on starting interval notation. There's a lot more to it, but we'll leave it at that for now. Best of luck.